In this section, you will learn to use proportions with similar triangles. You will also use proportions with a triangle or parallel lines. So let's look at this figure here. You see that segment XY is parallel to segment AC, and these two sides, BA and BC, are divided such that BX over XA, which is here, BX over XA, equals BY over YC. This is a triangle proportionality theorem. I also want to remind you that triangle ABC is similar to triangle XBY because these are corresponding angles and they are congruent. So the two triangles are similar by AA. And other proportions that you need to keep in your mind, which are also true, are that BX over BA equals BY over BC equals XY over AC. And this is based on the fact that these two triangles are similar. So the triangle proportionality theorem is just a little bit different from the proportions that you get when you write the proportionality statement based on the similarity of two triangles. Okay, the converse of the proportionality theorem. So if now you are given that BX over XA, so that's BX over XA, equals BY over YC, if that is true, then you can conclude that the two lines are parallel. And in fact, this sketch is incorrect here. We want to make sure, let's cancel us. So you're not given that the lines are parallel, you conclude that the lines are parallel. Did you get that? So your original diagram should have been something like this. AX, B, Y, C, and you are given that BX over XA equals BY over YC. So you conclude that segment XY is parallel to segment AC. You're not given that. Now we have three parallel lines. So these are your parallel lines. 1, 2, 3. And we're saying if they are intersected by two transversals, and these are your transversals, then you divide those transversals in a proportion, and if you follow the pattern of the triangle proportionality, you get UW over WY equals VX over XZ. Imagine that if you extended these sides here, they might actually meet, but they don't have to. However, the proportionality still holds. So if you have parallel lines, it can be 3 or more. The transversals are divided proportionally. Completely different diagram right now. We have a triangle, and in this triangle we have a ray CD, and what ray CD is doing is it's creating two congruent angles at the vertex C. If that happens, okay, now pay attention here, if that happens, then AD over DB equals CA over CB. So the side that's divided by the angle bisector. You write that proportion down, and then the other side you write the side of the triangle that shares a vertex with part of the divided side. So for example, in AD and CA, they share the vertex A. In DB and CB, they share the vertex C. So this is helpful when you're writing your proportionality. Okay, in this diagram, you can set up a proportion based on the theorems above. You can call this X if you like. Set up a proportion and solve, and then check and see if your answer is 9. This is one where you're going to use the proportionality of transversals. So here's again, it says you need to find the distance between First Street 1 and Main. First Street 1. I don't know why there is a 1 here. First Street and Main Street. Where is Main Street? Let me just check that. Okay, this is Main Street. So you want to find the distance between, I'll highlight for you. You really want to find TV. Okay? So you could do it two ways. You could find TU and then maybe add it, or you could do QR over QS equals TU over TV. Your choice.